Good afternoon once again, future mathematicians and future mathematics teachers of our community. Welcome to the second part of the Unit 2, which is all about triangles. This time we will be discussing triangle similarity. In geometry, two polygons are similar when one is a replica or the scale model of the other.
I shall call him
Consider Dr. Evil and Minimi from Mike Mayer's hit movie Austin Powers. Minimi is supposed to be an exact replica of Dr. Evil. So these two are Minimi. So they are similar to one another. And maybe you, similar to one of your parents, maybe your mother or your father, or maybe one of your brothers or sisters. So these two smileys are also similar. The following are similar figures also. This figure is similar to this one, and this is also similar to this one. The following are non-similar figures. Take a look at this. This is a rectangle and this is a square, so they are not similar. These two triangles are also not similar because this is a right triangle while this is an example of obtuse triangle. Fifi, the mother cat, lost her daughters. Would you please help her to find her daughters? Her daughters have the similar footprint with their mother. So this is the footprint of Fifi. So she is looking for her daughters. Let us take a look where are the footprints of her daughters. Is this a footprint of her daughter? Question is this similar to Fifi's footprint? So no, this is not. How about this one? This is also not similar to this. How about this? Yes, this is similar to Fifi's footprint. So this is a footprint of Fifi's daughter. How about this one? Is this similar to this? Are they similar? Yes, they are similar. So this is probably a footprint of Fifi's daughter, and also this one. This is also a footprint of Fifi's daughter. So Fifi has 3 daughters here. Which of the following is similar to the above triangle? This one. Is it A, B, or C? So the answer is... So the answer here, which of the following is similar to the above triangle? Is it A, D, or C? So the answer is letter A. Similar triangles are triangles that have the same shape but not necessarily the same size. So upon looking into the sizes of the shapes of the triangles, you may say that these two are similar. So these two triangles are similar even though they do not have the same size. So we may say that triangle ABC is similar to triangle DEF. So this is the symbol for similarity. When we say that triangles are similar, there are several repercussions that come from it. So angle A is congruent to angle B. Then angle B is congruent to angle E. Then angle C is congruent to angle F. Then, since these two are similar, we may say that line segment AB over line segment DE, so AB over DE is equal to BC over EF equal to AC over DF. So these are the repercussions that come from the two triangles which are similar. 6 of those statements are true as a result of the similarity of the two triangles. However, if we need to prove that a pair of triangles are similar, how many of those statements do we need? Because we are working with triangles and the measure of the angles and sides are dependent on each other. We do not need all 6. Actually, there are 3 special combinations that we can use to prove similarity of triangles. So what are those 3 special combinations? The PPP similarity theorem, or at least 3 pairs of proportional sides. if the three pairs of proportional sides are if we have three pairs of proportional sides in two similar triangles or in two triangles, then we may say that the two triangles are similar. And then the next one is the PAP similarity theorem. We have two pairs of proportional sides and congruent angles between them, meaning the angle is included angle. It is in between the two proportional sides. Then the two triangles are similar. And then the last one is the AA similarity theorem. If we have two pairs of congruent angles in the two triangles, then that two triangles are all already similar. Let us dig with it one by one. The PPP similarity theorem, or the three pairs of proportional sides. So given the triangle ABC and triangle EFE or DEF. So AB is 5 and then DF is 4. So measure of line segment AB over measure of line segment DF is equal to 5 over 4 because these two line segments are the corresponding sides of these two similar triangles. And then we have BC, which correspond to EF. So BC is 12 and then EF is 9.6. So measure of line segment BC over measure of line segment FE. So you will have 12 divided by 9.6. That is also equal to 1.25. And then the last one is line segment AC, which is 13, and then line segment ED, which is also equal to 1.25. Let us divide 13 divided by 10.4 is equal to 1.25. Then 12 divided by 9.6 is also 1.25. Meaning, we have three pairs of proportional sides here since we have equal proportions. All of them are 1.25. So these two triangles are similar by PPP similarity theorem because of having three proportional sides. So if these two are similar triangles, then their corresponding angles are also congruent. So triangle ABC is similar to triangle DFE by PPP similarity theorem. How about the PAP similarity theorem? Two pairs of proportional sides and congruent angles between them, meaning the included angle. So suppose that we have here this triangle and another triangle. So let us prove that these two triangles are similar through a PAP similarity theorem. So GH corresponds to LK. So let us divide. So that's 5 over 7.5, which is equal to 0.666. And this angle is 70 degrees, so that angle K is also 70 degrees. So measure of angle H is equal to measure of angle K. And then let us take a look at line segment HI or side HI, which is 7. And then KJ, which is 10.5. Then we divide 7 by 10.5 to 0.66. So these two triangles are similar through PAP similarity theorem. So these are the two pairs of proportional sides plus the included angle. So the angle between them are congruent. The PAP similarity theorem does not work unless the congruent angles fall between the proportional sides. Yes, because if the angle do not fall in between the two proportional sides, then we cannot say that these two triangles are similar. So it's very important that the angle must fall in between the two proportional sides for the two triangles to be similar. For example, if we have the situation that is shown in the diagram below, we cannot state that the triangles are similar. We do not have the information that we need. For example, it's 5 and 7.5, that's 7 and 10.5, and the angle is in here at I, and the angle is in here at J. So though these two angles are congruent, we cannot say that these two triangles are similar because the angle do not fall in between the two proportional sides. So angles I and J do not fall in between sides GH and HI and sides LK and KJ respectively. And then the last one is the AA similarity theorem, where we should have two pairs of congruent angles. So given these two triangles, if angle N is 70 and angle N corresponds to R, which is also 70 degrees, then angle N is equal to angle R. If angle O is 50 degrees, which corresponds to angle P, which is also 50 degrees, then measure of angle O is equal to measure of angle P. If we already have two pairs of congruent angles in the two triangles, then we may say already that these two triangles are similar. So triangle MNO is similar to triangle QRP, where M corresponds to Q, N corresponds to R, O corresponds to P. It is possible for two triangles to be similar when they have two pairs of angles given, but only one of those given pairs are congruent. So suppose that we have these two triangles. So by the way, what type of triangles are these? These are similar triangles that we have to prove. Okay, suppose that this is 87 and 34, then this is 34, and then this is 59. So if this is 34 and this is 59, since T corresponds to X and U corresponds to Y, upon looking at it, we cannot have two pairs of congruent angles. But if we solve the measurement of the unknown angle, angle S, so we subtract 34 and 87 from 180. So 180 minus 34 minus 87 is 59. So we will be able to know that angle S is equal to 59. And angle S corresponds to C. And then angle X is 34, which are congruent to one another. And then you solve angle S is equal to 59. So there you go, we already have two pairs of congruent angles. So we may say that the two triangles are similar. TSU is similar to triangle XZY. Note that one triangle is a scale model of the other triangle in this case. So 10, CA corresponds to ZX, CB corresponds to ZY, then DA corresponds to YX. So these two triangles are scale model of one another. And these two triangles are similar through PPP. How do we know if two triangles are similar or proportional? Triangles are similar if corresponding angles are equal and the ratios of the lengths of corresponding sides are equal. So interior angles of triangles, as what we discussed in the previous lesson, the sum of the measure of the angles of the triangle is always 180 degrees. So measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Determine whether the pair of triangles is similar. Justify your answer. So this is 42, this is 42, and this is 96. So you want to give a try. If this is 96 and these two are congruent, what would be the remaining to 180? 180 minus 96 is equal to 84. And in the 84 degrees, two angles will be having that. So you divide 84 by 2, you will have 42 and 42. So this is 42 which corresponds to angle M. Angle R corresponds to angle M, and they are both 42. Angle T corresponds to angle O, and they are both 96. Since 42 plus 42 is 84, 180 minus 96 is 180 minus 84 is equal to 96. So angle O and angle T are congruent. So these two triangles are similar through AA similarity theorem. If the product of the extremes equals the product of the means, then a proportion exists. That's true. We learned that in our elementary days. So suppose that we have these two ratio and which form a proportion. A over B is equal to C over D. So we get the product of the extremes and the product of the means, and they are equal. So BC is equal to AD, the product of the extremes, and the product of the means equals the product of the extremes. So in this case, since these two are proportional, we may say that AB over XY is equal to K. And then K, so you will have 12 over 6 since AB is 12, and then XY is 6, so this is 2. The proportion is equal to 2. And then BC over YC is equal to K also. So you will have 8 over 4, which is 2, so K is equal to 2. And then in here, AC over XC is equal to K, so K is equal to 2 also. So these tell us that triangle ABC and triangle XYZ are similar and proportional because they have the common proportion, which is 2. Can these triangles be similar? So as you can see, we have here 10 and 8, then 8 and 6, then 6 and 4. Let us try. 10 divided by 8. So 10 divided by 8 is equal to 1.25. Here, 10 divided by 8 is 1.25. Then 8 divided by 6 is 1.33. So that means that these two triangles, so we have 8 divided by 6 is equal to 1.33. So you will have 6 over 4 equals 8 over 6 equals 10 over 8 equals K. And then simplifying this, do we have equality? So 6.4 is 1.5, but 8 over 6 is equal to 1.333. This tells us our triangles are not similar. You can have two different scaling factors. So meaning these two triangles are not similar upon using the criteria, but upon looking into its figure, they are similar. But using the criteria and by computing, using the measurement of their sides, we can prove that these two are not similar. If we are given that two triangles are similar or proportional, what we can determine about the triangles? The two triangles below are known to be similar. So given that these two triangles are similar already, determine the missing value. So how can we solve for x? Take note that x corresponds to this side with measurement of 4.5. So we are going to use this one, 7.5 over 5, because they are corresponding sides, is equal to 4.5 over x. Or you may also use 4 or 6 over 4 equals 4.5 over x. It's up to you because you will still have the same answer. Then, getting the product of the means equals the product of the extremes. You will have to multiply 5 times 4.5 is equal to 7.5x. So 5 times 4.5 is 22.5 equals 7.5x. Then by applying the division property of multiplication, we divide the whole equation by 7.5. So the value of x is already 3. In the figure, the two triangles are also similar, where this side corresponds to here, and then this side, C, the unknown variable, corresponds to this side with the measurement of 4. So we are going to solve for C here. So we may use 10 over 5 is equal to C over 4. Then by cross multiplying, you will have 10 by 4 is 40. 5 times C is 5C. Solve for C, divide the whole equation by 5. So C is equal to 8. So the value of C here is 8. Or we may use the other pair to solve for D at this time. So you have 10 over 5 equals 6 over D. By cross multiplication, you will have 6 times 5 is 30, then 10 times D is equal to 10D. Divide the whole equation by 10, so 3 is equal to D, or the value of D here is equal to 3. Sometimes, we need to measure a distance indirectly. A common method of indirect measurement is the use of similar triangles. So in this case, we have here a man and a tree. So our task is to solve for the height of the tree. And then here, here's the shadow of the tree and the shadow of the man. So the shadow of the man is 17, and then the length of the shadow of the tree is 102 from their foot. The height of the man is 6. So we may use 17 over 122 here. The length of the shadows of the two is equal to 6, which is the height of the man, over h, which is the height of the tree. So by doing the cross multiplication, you will have 36 equals h, because 17 times h is 17h, then 6 times 102 divided by 17 is equal to 36. So the height of the tree is equal to 36. By the way, if you still have questions with regards to triangle similarity, please feel free to send me a message in our group chat, and I will be very much willing to answer all of those. Thank you very much, and God bless. See you all soon.